Yeah, okay. So recordings are started now. So hey, welcome all of you guys. Myself Suji. I'm your host and host for your today's session. Working as a research intern and a diploma level student at IIT Madras and leading this community from past 8 months. So we are continuing our AWS AI series. So last session we are discussed about generative AI, how AI getting evolved to generative AI, and how it's moving towards agentic AI. In today's industry, mostly things are getting automated with AI agents and that all. We are seeing already coding is also getting automated with AI agents like Cursor and Copilot and that all. So we are have to be updated with this thing technology. So we have planned this session about agentic AI. So today we have Ananya ma'am. She is a developer advocate for generative AI at AWS. So she's coming with a vast experience in generative AI and AI agent from going from designing and developing and going toward the production side. So ma'am have a really good experience. We have already saw her magic in the last session. People really like the session, how the way she's teaching and the way she explains. So we really got too much request for this session too. Still, we didn't. Last time we had the holiday, so we got quite good audience. Today also we have crossed 50 plus. We'll wait for some people to join. So yeah, I'll just give a small intro about ma'am. Ma'am work at the AWS. So without a further delay, ma'am, you can start it.
Sure. Thank you, Sujit, and welcome everyone. Hope you are doing well. I'll start sharing my screen. If I can get some thumbs up in the chat once you are able to see it. Great, great. Okay. So, before we move on to the AI agents, I remember last time we talked about generative AI. We will also talk about one very core service from AWS, which is Amazon Bedrock. And then we will move on to the agentic AI side. So, in AWS, we have a lot of AI services and a lot of the applications which help us to build AI agents, to interact with the models, to interact with LLMs, to interact with agents. A very core service that we use is Kiro, which is our ID, the platform where we give prompts, we give instructions, and us to generate code. It helps us to generate specifications. Just giving you how in an industry works. Now, while you are a student, you might be writing codes on any of your ID, any choice of your ID that you use. In the enterprise side, what happens is when you want to write a code, before you even write code, something called as requirements come up. Yeah. So before you even start with your just a second, let me start with the pointer. Yeah. So before you even have something called as your code, this is your step last, you have something called as requirements. Then you have something called as design. Then you have architecture, and then finally something code. So what happens when you get a statement from a particular customer, from your end user, that you need to build a particular solution or app for any of the problems that you have? You start with the requirements. Then you find out whether this particular solution can be built with Python, you can build it with Java, what kind of libraries you need, what kind of features you will require, what kind of other tech services you would need, what models you would use, will all come in the requirement phase. Then comes something as design phase. In the design phase, now you have listed, let's say I'll do it with Python, I will use the let's say Nova model. So something like these you have all listed down. Let's say some JavaScript libraries will be used, you will use Angular to build your front end. So all these kind of requirements you have decided. You have decided there needs to be a feature for clicking a button, you have seen a feature for drop down, you have done a lot of requirement gathering. Then you come to the design phase. Now, with all the requirements, let's say you have figured out 20 requirements. With all these 20 requirements, you will design your solution. For example, when I click the button, what happens? When I select a particular value from the drop down, what happens? When I submit a form, what happens? So, these kind of things come in your design phase. And finally comes the architecture. In the architecture, what you decide is, let's say you can do it on a server, or you can do it on a serverless architecture. Now, there is a very simple difference. Server is something you manage yourself, it's a physical instance. Serverless is something which is managed by the cloud provider, and it's not a physical entity per se that you have to manage, but there are certain virtual machines running in the backend on which your code will run. So, these kind of architecture decisions you will take in the architecture step. Now, this particular ID from AWS, it helps to design all the three once you have given it a prompt. So you give it a prompt. Remember, we discussed what prompts are from the last time. We give instructions, context, input, examples, and then it generates your response. So similarly, we give a prompt to Kiro, and then finally Kiro generates all your requirements, design, and architecture. Finally, when you have signed off on your three different stages, it will generate the right code that you can run for the solution that you have given in your prompt. So, let's say you wanted to build an exam generator, you wanted to build a question answer app. So, it will generate the code for the same. Now, this is ID we use. Moving on, we start with something called as Amazon Bedrock. This is one of the very important platforms which service which helps us to provide access to the models via APIs. Now you cannot directly interact with the different models that are there. Let's say it's a Nova model, it's a Claude model. You cannot directly interact with them. You need to have APIs. And that's what Amazon Bedrock is going to provide you. It provides you the APIs you can actually use to access these models. And then it also provides guardrails. So what happens in guardrails is you basically check what kind of tokens are consumed, how many tokens are consumed, how the tokenization is happening. You take note of what kind of content is getting generated. Is it harmful content, it is violent content or not? So these kind of guardrails you will check under the guardrails capabilities. Then you can also do model optimization. So for example, let's say your model is performing very good when you are doing question answer scenarios, but it is not performing very well on the summarization tasks. So that is somewhere in Bedrock you have capabilities of model optimization and customization to tune into your particular solutions. I'll go into the UI console to show you how Bedrock looks like. Let me just go to the Chrome tab. So this is a console you will see. Uh, this time, let me close. Yeah. So this is the console you will see. Because I've visited a lot of services, I'm able to see the recent services I have visited on my Amazon console. When you come for the first time, this is empty. You can search for Amazon Bedrock. You can just write Bedrock, and it shows you Amazon Bedrock. Now, in Bedrock, there are different things that you can do. You can start with looking at the different models. I hope it's visible. Let me zoom in a bit. So it starts with models, which is listed in the model catalog. You have n number of models that are there from different Amazon and third party providers. Starting with, if you just want to look at what models Amazon is providing, what kind of features that they have, what is a Nova multi model, what is a Nova Sonic. Similarly, let's say you want to go via Anthropic, you can do the same thing. For code generation, you pick up Sonnet 4.5. For any other text enhanced thinking, agentic thinking, you pick up Haiku. So these kind of models you can go and check here. Plus, you can go to your playground and you can start chatting with a particular model and try out your query. So let's say I select Anthropic Sonnet 4.5, I apply, and I say, can you tell me what is Amazon Bedrock? I'm just putting this particular question. You can put in whatever questions you have. It will think, it will then generate answers. So before you even try on your local, you incur cost, you can try actually in the chat playground, see what kind of models you would like to use, what is your input length token, what is your output length token, then how much time it took to generate the answers, and all these kind of insights you can get in the Bedrock. Going back to Bedrock, you can try, this is one use case from chat. You can go with image, you can go with videos, you can try different watermark detection, you can try different tokenizers that are there. You can start with the for my use, I generally use the Titan text generator, because text embeddings and the generator, so that it does the optimized text tokenization and embedding generation. Then there are different other features, something called as agents, which we will come little later once I have shown you. I'll go and show you very keen things on guardrails. So, guardrails are nothing but it safeguards your LLMs and your outputs that the LLMs will generate. It follows the AI ethics and the responsible AI policies. Now, in today's world, we all know that AI, unless it is a human controlled AI, it may or may not be feasible to generate correct answers always. Hence, we would need such policies where we can monitor what our responses are coming. So, going on, you can just enter a name. I'll say test guardrail. In production, we generally have good names and nomenclatures which follow the principles of the design and the architecture. For the for this particular session, I'm showing you test guard, and you can then select what kind of tags you want to add in it. Let's say I want to check whether harmful categories are getting generated, or maybe in some cases I don't want this to be tagged because I want to see what kind of harmful categories are getting generated, and it will be use case specific. Let me give you an example. Let's say there is a healthcare scenario. You want the model to generate what kind of situations will lead up to a cancer. And in those scenarios, when you ask a prompt, you generally want certain responses which will tell you how a person can get cancer, what are the symptoms, what are the post medical, I would say, treatments required. So these kind of filters will be different for a case where you need certain categories to be generated. In certain scenarios, let's say you just want to know what kind of medication is required for a fever, you definitely do not want your model to give you very harmful medicine names, and hence you can add harmful categories as a filter there. So two different scenarios from the same particular domain, which is healthcare, but your prompts and your responsible AI guardrails will be different for them. However, certain filters like violence, content, and these kind of always filters should be enabled. That is one of the responsible AI principles you should always follow. Now, coming to prompt management. So remember I showed you how different kind of promptings happen: zero shot, one shot, few shot, and then also chain of thought prompting. So even before pushing your prompt into production, you can start with writing your prompt, testing out the prompt here, seeing how the tokenization is happening, see how the prompt is generating the response. Once you are satisfied that your prompt is generating the right responses, then you can actually deploy the prompt in your production instance. So there are a lot of things you can do in Bedrock. This was one thing which was left from the previous session. hence wanted to cover it. Now we'll move on to the agents, and then finally how you can build your simple agents to going and deploying your agents with agent core. Any questions for Bedrock till here?
Ma'am, I have one question.
Yeah.
Question is like when you are selecting the specific models for
Mhm.
your design phase,
Yes.
that is kind of like you are adding APIs, selective APIs, whatever you need for the design.
Yes, you are right. So each of the models that you see here are available through APIs. Whichever model you are allowing in your playground or in your application, those only will be those APIs only will be available, and you can interact with those models only.
Okay, ma'am.
Yeah.
And one more question is like, I mean, these APIs are controlled APIs. Like whatever features you want to include, only those you
Yes.
can use. Others you can exclude like that, right?
Yes. Yes. Exactly. Exactly. And let me show you here how we are controlling the different models. Now, I told you, right, in the models, we have certain capabilities also along with the models. With the customization and the optimization, you can select and apply different parameters. Like for some models, you want a high temperature, some models, you want a low temperature. Like temperature defines your randomness of how the responses should be generated. If it's 0, then your response is very strict, and from the data that you have given, it has to follow certain language. If you give it a 1 temperature or more higher temperature, if you give, it is going to generate content which is very random, very unique. So these kind of capabilities and I would say customizations will come along with the models, and it is very dependent on the models that you choose, and you can customize them according to your need.
Okay, ma'am. Thank you.
Yeah. Thank you. Moving on, these are some things which I already showed you in the UI, so I will not go through them. The Amazon Bedrock is being used by developers, and we just had this AI for Bharat initiative where a lot of developers from India came together. They built chatbots, they built virtual assistants, they also did multiple use cases on summarization, content generation. Now the learning from the learning phase, now we have shifted to the build phase where the participants are using Amazon Bedrock to actually build particular solutions from different domains. One, I think, is healthcare and life sciences, another is farmers, sustainable development, and environmental and governance policies. So a lot of things developers are doing with Amazon Bedrock. It has different models as I showed you on the UI. So moving on. Now, if I can get some answers in the chat for this. Can you have more than one custom model in Amazon Bedrock? If anyone can answer, like, I'll just keep 1 second. I'll come back to the group. Yes, yes. Okay, okay. If someone can unmute and explain to me what is a custom model and what is a foundation model. I had told this the last time. If someone can unmute and tell me. Okay, Mudita, see you have raised your hand.
Yeah, Nanya. So, foundation model is like the ones that are already existing, like Claude or GPT, or what we have, if we have anything from Amazon as well. Custom model has the capability of domain integrated into it. So, it could be a healthcare specific model that has been built by the organization for the purpose of meeting the organization needs. It's very domain specific. That's my understanding of custom model.
Okay, Shankar, you want to add something to this? Shankar, I see your hand raised.
Yes, ma'am.
Yeah.
Ma'am, custom model is something that we actually built on top of the existing models by Actually, like we are, I mean, uh, we are, I mean, what we are actually modifying the model according to our needs. Like
You are
I can't remember the exact word, but
yeah.
we are actually, uh, manipulating the model in the sense,
Yes.
and then we can use according to our needs. For example, if we are using any model for any healthcare needs, we
Hmm.
will be feeding the data according to the healthcare, right? And
Agreed.
apart from that, the if we're using the education, so we will also like feed the education data only according to that.
Yes. So, both Shankha and Mudita, you are right to some extent where you said that you are going to change the model, or you are going to add certain parameters, or customize the model to your needs or your data. So, one simple use case of model customization is fine tuning, where you add the data to it and you train your model and change the model weights. That is one way to look at it. Customizations could be, you have the same model, but you just want your model to learn the data nuances or the domain nuances, or you want the model to totally learn a new language altogether from the previous languages it has learned. So different kind of customizations can happen. And you can have more than one custom models in your Amazon Bedrock at the same time. You can even choose Amazon models as one of the custom models and train your model on it. You can also select Anthropic, so even different service providers are allowed, different custom models are allowed. If you have built a model of your own, let's say a regression model, but you now want that regression model to also predict some financial data, learn from financial data from the LLMs, those things also you can upload and customize according to the need. Moving on, now we'll shift the narrative to AI agents, but before we do that, let me give you an understanding of how this shift happened. So initially, we were talking to the LLMs and they were talking back in the generative AI era. But we as developers quickly figured out that just talking to LLMs won't help us. Summarization and the Q&A is good, but unless an agent can take an action, or some LLMs or some models can take an action on our behalf, we are not going to be satisfied with the responses getting generated simply. So that is where AI agents came in. They would be mimicking exactly human thinking. They could reason, they could plan, and they could act on your behalf. So, for example, let's say your professor must have given you an assignment. How you would think of breaking down that assignment into logical steps? So, day one, I do a research on what kind of topic I would write. Day two, I would research on additional topic and some research papers I would go through. Day three, I start writing the headers of the assignment. Day four, I write the content of the assignment. Day five, I validate and submit the assignment. So this is how a human is reasoning, planning, and acting on a particular data or a assignment or a task. The same thing AI agents are doing either in digital or physical environments. So, how the AI agents would take action on your behalf is what we are going to learn. Now, there are different uh, platforms, services which you can use. We'll focus on Strands agents because this is open source SDK for building agents, and it's a low code, no code solution where, in very simple few lines of code, you build your agents, be it a single agent, be it a multi agent, be it agentic workflows that you want to build. You can start writing your code with it. But before we go on to that, let's look at what happens when we say it's agentic AI at the base. So it starts with, let me start the pointer again. So always step one is when you give it an input, you give it an instruction. Agents also work in the same way. They receive input, then they start with the reasoning, which is step 2. They break down the particular input or the instruction into different steps. So let's say you said do math homework of uh, binomial fraction something. Yeah. So now it will start thinking. For doing a math homework, first I need math libraries, I would need calculator, I would need what is binomial fraction. Yeah, it will think of these ways. Now it is reasoning that first I will take the action, I will take the input, I will break it down into reasoning steps. Then it starts selecting tools, because not all information, we established this in the generative AI era, where when we asked questions like, hey, what is the weather today, to an LLM, it was not able to respond back because it does not have recent context, it does not have the latest information with it. It is always containing the information till the date it was trained on. So that is where the agent started bringing tools to their context. It can search the web, it can go to a database to search information, it can do certain calculations, it can perform actions. So that is where it starts with selecting the tools and the libraries. So let's say here in the reasoning step, it remembers in math library I need plus, I need minus, I need multiplication. Just giving you random ideas. Now it knows in the tool selection, I need a tool for doing a plus, I need a tool for doing a minus, I need a tool for doing multiplication. So it will select the relevant tools. Once it has selected the relevant tools, then it starts executing these tools. Now it knows I have to do, let's say, a plus b whole square. This was my initial action that it had to take. So now it starts doing that. Now to do a plus b whole square, I would say a square plus b square plus 2ab. Now this is the actual formula that would break down for a plus b whole square. When it starts doing a square b square, it suddenly knows, hey, I don't know what a square is. How do I do a square? It does not know right now that a into a will give it a square. So when it gets this new information, it again goes back to the reasoning step. It starts thinking, hey, what I have to do when I have to do a square. So the loop continues. It reasons, it selects the tool, and it executes the tool. Now, when it knows that I have to do a square के लिए a into a, it will execute that step. And this loop continues till my response is generated for this. And once my response is generated and the agent is satisfied that this is my final response, it goes and gives the response to the user. So this is how agentic loop works. It starts with a very simple input, but internally there is a three-step running. Starts with reasoning, tool selection, and tool execution. And in between, if it needs new information, it again goes back to the reasoning step and does the thinking all over again. Okay. Now, with agents, you have different capabilities that you want. You have different models that you can select. You have multi-agent integration, you have agent to agent integration, you have something called as MCP integration. Does anyone here know what is MCP or heard of what is MCP? You can
Yes,
just
ma'am.
unmute and
Yes, ma'am.
Uh, yes, ma'am. I have heard about the MCP servers. So in the MCP servers, what we do is we just integrate the like API keys into the agentic AI IDs. Like for example, we have Cairo.
okay.
So in the Cairo, we just integrate the MCP servers ID, like sorry, API keys. So the reason for integrating this kind of API keys into an agentic AI ID is that This API key or the MCP servers will like help the IDE to connect the appropriate services or
Okay.
appropriate like, for example, if we want to use the Supabase, so we have the Supabase API key. We can give the configuration of that Supabase into the any agentic ID. Like, for
Yes.
example, we're having Cairo. So,
Mhm.
ma'am, I have a question. Like, I have already sent that in the comment box. I have used the different agentic AI IDs like Cairo. Nowadays, we're having anti-gravity by Google. So
Okay.
I'm hitting some roadblocks because the number of tokens of any model that we use, any agentic AI ID, is actually limited. And while building applications, like if you are building a small projects for like nowadays everyone is using agentic AI for building the projects. So I have tried to build some projects, but where failing is it can generate the front end codes properly, and it's creating amazing front ends. But while creating the backend, while we want to integrate the backend or any database, it's creating numerous number of errors. Like for example, a few common errors I have seen is like module not found errors, and it is creating some
Okay.
routes while we are.
Let me stop you here. What we can do is, for your errors, I'll help you in a different chat, or maybe after this session. I'll continue this session and then we can come back and discuss the errors, because maybe a lot of other student developers are also facing the same issue. So it's good to have a broad discussion on this, and I can help you with that. Does that sound good?
Yes, ma'am. Thank you, ma'am.
Yeah. Okay. Okay, coming back. So, MCPs, as your friend rightly mentioned, it is something where you give it API nomenclature. So, for example, let's say think of you who has to buy some eggs. Okay, now you go to a supermarket. You don't know there is brown egg, there is white egg, there is something called as quail egg, ostrich egg. Just giving you examples. Elephant, I don't know, elephant don't have egg, but let's say kiwi bird which has egg. So these kind of eggs are there. Now you as a person is very confused. Hey, what kind of egg do I buy? I don't know what particular eggs do, what vitamin, what nutrition, what efficiency they have, what kind of proteins they have. So you're very confused which kind of egg to buy. Now let's say there was a helper in that supermart who knew what kind of proteins these eggs contain. Let's say this is 35 gram, this is 20 gram, quail egg, let's say, has 10 gram, ostrich egg, let's say 25 grams, something like that. Yeah. Now this helper knows these kind of proteins is available in each of the eggs, right? And he tells you, if you buy kiwi egg, you get 35 gram of protein. If you buy quail egg, you get 10 gram of protein. But let's say some kind of other parameters are there, fats and lipids, something is there. Yeah. Now, these kind of information is being maintained by this helper. You, as a buyer, will just go ask the helper, I need 20 gram of protein every day. What kind of egg I should consume? It will tell you go for brown eggs. Same thing is what MCP does. This MCP server here, this is the MCP server. It maintains protocols to different APIs, services, libraries, tools. There could be n number of things that happen in the backend. This server maintains protocols. Yeah, it maintains protocols, and it lets the agent, in this case, it will be an agent, know how to communicate with these protocols. The agent will just send the request and forget how the response will come. The server will take care of talking to the API or the service, etc., and get the response for the agent. Similarly, how the helper was helping you buy the right egg without you worrying what kind of proteins, fats, and other nutrition is available in that egg. That is what MCP is. And when I add another agent, let's say this agent was doing plus, this agent is doing multiplication. Now, when these two start talking, it's agent to agent communication. You can add custom tools to your agents. You can add multiple LLMs. You can connect with multiple LLMs. And as part of this agents, you can also integrate with different services. Let's say you want to integrate an agent to fetch information from S3, maintain information on DynamoDB, maybe deploy some services on AWS Amplify. So all different kind of AWS service integration and other integrations are also possible. Now, it's very simple in Strands agent how we write code. It's very simple because it starts with Strands library, and from that you import this class, which is agent. You create an object of the agent and you just invoke that agent. Now, this is a very simple agent. You once you run this particular program, let's say you have done agent.py, agent1.py as your class name, and when you run this will just keep on saying hi. The number of times you run it, it will say hi. Hi. This is a very simple agent. But see how with Strands agent, you don't have to write a lot of code to create your agents. Moving on, if you want to add tools to your agent, and you will at certain point, because let's say you want to search the web, let's say you want to get the weather information, let's say you want to summarize information from different websites, research papers, and other databases that you have in your local or in external. So you will need tools for that. A very simple tool here which we are showing is HTTP request. The same thing, I start with calling the agent class from Strands, HTTP request function from Strands tools, and then in my agent, see in the previous one how we did just simple agent object creation. Here when I create the object, I tell this particular agent also add tools to your tools to your agent instantiation. So what it will do is it will add HTTP request as a tools. Now these kind of tools are already created. These are pre-built tools. It knows, these tools knows what is their action that they have to take. In this case, the action is searching the web using HTTP. It could be a simple summation also that you want to do. So math tools you would import. If there is any other thing like weather information, you have the weather API tools for getting that. So different kind of tools, a lot of pre-built tools are already available in the market, which you can use with your agents. And once you have given it the tool, and now if you ask it the question, where is the International Space Station, or what is the weather in Bangalore or Chennai today, or how to travel from Chennai to Bangalore, so these kind of information it will be able to get for you, because it will now go to the web, search the information, and get the information for you using these pre-built tools. But with Strands agents, just remember, it's not just the let me go back to the previous one. It's not just the pre-built tools that are available. You also have something called as custom tools. So let's say along with HTTP request, now this is a very generic HTTP request. It will search all the information that is there on the web. You just wanted a health database, or you just wanted a financial database search or financial website search. So you can create your own tools by listing the all the 50 or 60 websites that you wanted to search. You can just keep a array of those, and you can give those pre-built tools to your particular tools repo. Yeah. Now, with Strands agents, you can choose any kind of models. It starts with Bedrock models and your custom models. First, let's look at how it invokes models from Bedrock. So, again, agent class, Bedrock class. Once you have instantiated this, you create the object of Bedrock model, and here you tell which kind of model you would like to use. You give the model ID. And see, I have created two different objects, Bedrock model 1 and Bedrock model 2. In the first one, I am telling that what kind of parameters and their values it should use. Like the output that should come from this agent should have 1600 max tokens. And the response temperature could be zero point 0.7, like not too strict, not too random. But in the second one, I have not given it params. So this particular, if a agent uses Bedrock Model 2, it will generate random answers or it will generate strict answers based on its own interpretation because I've not given it any parameters. Both ways work. It will depend on different use cases. If you are doing a use case on defense, I would suggest go for the first one. If you are doing a very simple use case of, let's say, nutrition, you can go for the second one. Yeah. Now it's again very simple. Once you have given the models, remember in the previous one we gave tools. Here I'm giving the agent model. And then I'm asking simple question. Tell me about Bedrock. Also, you have other integrations, not only Bedrock, you can go via Light LLM also. Again, same thing, Light LLM, you take the model ID, you give the parameters, you invoke the model in the same way. And this is what I was talking about. You can create your custom tools. It's not only the pre-built tools that are there, but also custom tools. The only difference here is you would have to add the decorator of @tool to your function that you want to act as a custom tool. In this scenario, in the HTTP request, if you would have asked what's the weather in Seattle today, it would have gone to the different websites, weather websites, weather information directory, and it would have searched and generated whatever response it would have got, whatever language it would have used. It could have generated 5 sentences in one paragraph. However, because in this custom tool you have said you get the city, you get the days, you get the weather, and then return that weather forecast for this cities for the next days is, let's say, rainy. I'm just typing anything. So after this particular sentence it will start generating. Any questions still here? Anyone? Just give me a moment. Yeah, I'm back. Okay, since there are no questions, I'll move on. Now, as I mentioned, you can integrate agents with a lot of AWS services, but we'll not go through that. Let's answer some questions. Which models can you use with Strands agents? Is it only Bedrock or external or both or just Nova models? If anyone, if you can answer in the chat.
Both A and B, ma'am.
Okay. I see few answers in the chat. Okay. Okay. That's right. You can use both both Bedrock and external models. And it's not only Nova models, it's any model that you have in Bedrock. Great. Now, the very key thing of agents and LLMs is conversations and how it maintains those conversations. So something called as states and sessions we'll look at. So let's say you are talking to your friend and you start asking, what do you want to eat today? And your friend says, can I have a pizza? And then you say, what kind of pizza? Your friend says, pineapple pizza. Then you ask, do you want a large pizza or a regular pizza? Your friend says, a large pizza. So see how the conversation is evolving. You remember your friend had said pizza, then pineapple pizza, then a large pizza. So you are remembering all the different steps in the conversation. Similarly, an agent also needs to remember different conversation states so as to generate a wholesome output. And that is why we have something called as session and conversation manager. What if when you started talking to your friend, you said, what would you like to eat today? And he would have said pizza. And then you said, what is pizza? And then he would have said, pizza is a flatbread which comes in round shape. And then you say, what pizza would you eat? Then he said pineapple pizza, but you don't remember what is pizza. And you again ask, what is pizza? Would your friend be frustrated? Yes, because he would be like, hey, why are you asking the same question to me over and over again? What is pizza? So you would have to remember the conversations. And that is how Strands Agents is also remembering the conversations. Now, there are different ways how it remembers the conversations, different techniques I will show you. What three important things it should maintain is history, state, and metadata. Yeah. Let's say whatever conversations or sessions I am having, the first one was about generative AI. So now, when I talked in the initial stage about tokens, about embeddings, about vectors, you remembered in the last session, that is history of whatever was being taught. Then, in this current conversation, I am talking about agents, I'm talking about tools, I'm talking about models. You remember we talked about bedrock. So the state of the conversation is there. Then about bedrock models, you remember there is Amazon models, there is 3P models, there is Anthropic may Claude models, Claude Opus, Claude Sonnet, all these kind of information you remember. That's metadata of the information. What kind of version, what kind of tokens, how many parameters, all these becomes your metadata. So these three things is being saved and restored at every conversation step. Now, there are two techniques very familiar for conversation management. The first one is sliding window conversation. What happens in this is you keep a fixed number of most recent messages and discard whatever is old. So let's say you started talking to your friend about pizza, and then once he said, order a large pineapple pizza, you remembered that conversation and you forgot everything else. You went ahead and you ordered the pineapple pizza, right? And then once the pineapple pizza was delivered to you, you asked your friend, you ordered a pineapple large pizza? He said yes. You remembered that? But you don't remember all the 10 steps that you had started with. What do you want to eat? What is a large pizza? What is a pineapple pizza? You don't remember all those conversations. You just remember he ordered for a large pineapple pizza and you forgot all the previous conversations. That's how a sliding conversation manager works. If there are 20 conversations and you have said the conversation manager needs to remember only 10 conversations, so it will remember the latest 10 conversation and forget the previous 10 that had happened in the 20 conversation. When it comes to the second type, which is summarizing conversation manager, it works a little differently. Now it will remember all 20 conversation, but because you have said remember up to 10 conversations, it will remember the recent 10 conversations plus the summary of the first 10. It will not forget what has happened in the first 10, but it will remember the summary of it. For example, you talk to your friend about pizza, you just remember that I had started by asking what kind of food you would like to have, and then he said a large pineapple pizza. Yep. So, summary plus the latest conversations. Excuse me. So, summary plus the latest conversations, how many you have kept as the limit. Any questions on the conversation management or the two different techniques that are there?
I have a question.
Yeah.
Ma'am, when we are talking about sliding window conversation manager or summary manager, ma'am, in both the cases, the conversations, like you said, up to 10 conversations, considering up to 10 conversations are remembered. So, ma'am, those 10 conversations are in the context window or they are kept separately
Okay.
when we are calling the LLM.
It is in the context window. You are correct. So, be it any kind of conversation management you are using, these two are the ones which industry uses. You can have your own conversation management technique. For example, you can maintain the complete conversation in a S3 and then invoke the whole conversation when you are sending a context to an LLM. But you are right,
Correct.
it is sent in the context of the LLM. So you remember we talked about when we give a prompt to a particular LLM, we have input, we have instructions, we have context. In that context is where I will give this conversation history, be it summary or sliding window.
Ma'am, so it does not work exactly like RAG. It is working like a normal prompt, but it is adding this context to that prompt.
Yes,
All right.
yes. So when you add a particular context, it modifies the LLM's behavior, not the weights, but the behavior of how it will act in the next step.
Got it, ma'am.
Yep. Okay. Now, I will not get into the codes because I will be sharing these slides to you at the end. So you can look at the codes just showing you how the context is maintained. So first you start with uh, invoking the library. You give it content, you give it the text. Hello, my name is Alex. How would I like to help you? These kind of conversations you are having with the agent. And now when you ask it, what is my name, it remembers because here in the messages you have given it. Now to an agent you give messages, but messages, this is basically context. Yeah. Conversation manager, just the code becomes a little different, where in the messages you say conversation manager, you would like to have a sliding window conversation manager, or you would like to have a summarizing conversation manager. So both just differ in this way, like window size and the type of library and the class you are invoking. Now, coming back to hooks. In hooks, what happens is you are modifying the behavior of an agent. For example, when your friend said, I would like to have a large pineapple pizza, before that, you did not know what is a pizza. So you had asked, what is a pizza? What do you would like to have now, a large pizza or a regular pizza? How do you know that there are two different kinds of pizza? Because you invoked a tool. You invoked a tool to get what kind of pizzas there are. Then, when he said a pineapple pizza, you modified your behavior to see what kind of pizzas there are and then selecting the pineapple pizza. So these kind of behavior modification that happens in an agent is hooks. So let's say I'll just draw a simple thing like pizza. It started with what is pizza, then moved on to, once you did not know what is pizza, you went to the web. So I'm giving you an example of tool call. You went to HTTP request, you found out what is pizza. Then you said, okay, pizza. What kind of pizza you would like to have? Chicken, pineapple, or let's say mushroom. Now you had context because you started invoking HTTP request and you modified your behavior. Earlier you did not know what is pizza, now you know what is pizza, but now you want to know the type of pizza. Once that person says pineapple pizza, you now modify your behavior to know, hey, what kind of pineapple pizza? Large or regular? So now you are modifying your behavior. Here you would have called another HTTP request to know what kind of size pizza are there. What size types of pizza are there. Then you say large or regular. Then finally you place a call and you order the large pizza of pineapple type. So this is how you modify an agent's behavior. You are giving it different tool executions at different steps, or maybe you are adding conversation history like we talked about. You give it context of the conversation and you modify its behavior. Here, if you would have asked, let's take a different example and say, you asked your friend pizza or burger. But before you made the choice as an agent, let's say this is an agent who had to make a choice what is pizza and burger, how would it know that? It would have gotten LLM context. So it would have called an LLM and it would have got what is pizza, what is burger. Then it would have asked the friend. Then it would have invoked HTTP request. So you can try out different permutation and combinations to modify an agent's behavior. And that's just simple. It's hooks with which you can modify an agent's behavior. Now, we will talk about the different patterns or agentic patterns that are there currently. The most common ones. The very simple one is where you have a supervisor and then you have experts who can do a task. For example, let's say you are having an assignment on your maths. Yeah. Someone is an expert in algebra, someone is an expert in differential calculus. So if your assignment was about finding out the mathematical expressions and algebraic expressions, you would have gone to the first friend who was an expert in algebraic expressions and algebraic mathematics, rather than the second one who was good in differential calculus. Same way, the first pattern is where a supervisor has a list of agents who can do tasks and are expert, and this particular supervisor acts as an orchestrator basically between you and the agents. It acts as an orchestrator of making a decision who is expert of a particular task and giving that particular task to that agent. The next task, someone else would be an expert, it would give to that agent. So this is the first agentic pattern where you have agent to agent interaction. Now this agent is interacting with this agent, one to many interactions. Yeah. The next very common pattern is hierarchical agents. Now same thing, let's say you had to do a math assignment, you got differential calculus, and differential calculus may now you have integration or differentiation, and you also have something else, right? So now you give that particular assignment to your planner. The planner thinks, hey, which particular assignment is this? It knows differential calculus, it goes to supervisor 1. Supervisor 1 now decides, is it differentiation, is it integration? So it, let's say, knows A does integration, B does differentiation, and this is an assignment of differentiation, so it goes to agent B. So that is how hierarchy happens. Now what will happen is there is one to many and then again many to many. So this agent planner gave task to supervisor, supervisor gave task to another expert of that particular task. So this is another pattern of hierarchy. Here the different agents are segregated by roles or by departments. This is a classic example of departments where, let's say, student department or faculty department are experts of their domain, and then department heads or HODs are responsible for, let's say, giving curriculum, courses, tasks to those professors or students. And then finally there is admin who gives tasks, or college head who gives tasks to these HODs, and then HODs finally delegate the task to the lower agents. Now, there is something very important which is peer to peer agent. In this, there is a many to many conversation between agents. Agent A can talk to agent B can talk to C can talk to D can talk to again E or B, something like that. So, any agent can talk to any agent. B can also talk to E. Uh, yeah, A can talk to D, something like that. So this is a graph network because each and every agent is connected to each and every agent. Let's say, let's take an example of finding information from the websites. Okay, you want to find out what happens when you take paracetamol, or what happens to a 5-year-old who takes paracetamol, and you have given that to your first agent. The first agent thinks this is medical domain, this is healthcare domain, this is life sciences domain. According to that, it knows this is medical domain, it goes to agent B. Agent B now thinks this is drugs, this is generic medicine, this is what kind of medicine. So it knows it's generic medicine, so it goes to agent E. Agent E knows that this is paracetamol, what kind of molecular composition. So again, it could be connected to multiple agents. It gets that information, gives it back to agent B, B to A. A then summarizes all the information and gives back the result. So many to many conversation are happening. At each and every step, the agent is thinking and taking a decision before passing on the particular task to the next agent. So this is a graph type of network. Any questions in these three different patterns that we just talked about? Okay. Now, let's go into a question. Can you use strand agent hooks before and after tool calls to modify the agent behavior? If you can answer in the chat. Meanwhile, you answer. I see some questions. Ma'am, do we get these agents pre-trained, or do we have to train or build individual agents? So, Aryan, to your question, you have agents built for your use case. You have generic agents, for example, planner, retriever, analyzer, that do the same things over and over again. So you don't need to train them. But you can build your own agents. Again, agent training is not such a thing. However, you would use the LLMs, which are either pre-trained or you customize with your own data. But you can build your own custom agents. For example, you have to research on a book, you have to write an autobiography. So these kind of things, you would build your own agents. Okay.
Ma'am, I have one question.
Yeah.
It's like agent to agent interaction, that's part of architecture, right?
Yes.
Okay, ma'am. And we have to decide based on the use case what architecture we have to follow.
Yes, definitely. So if you think your agents need to talk to each and every agent, for example, in the example I gave before, there is a supervisor agent who knows that a particular agent is expert in healthcare, another is expert in retail, another is expert in education. So those kind of decisions you would have to take and decide which kind of framework you would need or which kind of pattern you would need to deploy.
Okay, ma'am. Thank you.
Yeah. Okay, so the ones who answered yes for this particular question, you are right. You can use tools, LLMs, conversation history to modify the agent's behavior before and after. Now, Even though you have done all agents, you have built your agents, you followed all architecture patterns, let's say graph pattern or peer to peer pattern or supervisor pattern, whatever kind of pattern you followed, it's still hard to get these agents into production. First is because when you execute these agents, you need to make sure they are secure and they are securely executing your information. It has to remember a lot of information from past interactions. Now when you build a simple agent, you might just want it to remember last 10 conversations or last 15 conversations, or maybe summary of 10 and then latest 10 conversations. But in production, when you have agents, they might have to remember information from days, from months, or maybe user specific information it has to remember, or day specific information it has to remember. So different kind of permutations might happen. Then it has to also be secure to access. For example, an admin can access all the databases, but you as a student might only be able to access the student database. Your professors can access professor plus student database. So these are the different access controls that need to be applied. Then agentic tool use. We just saw one or two tools that we use in very simple agents, but in production, one agent might talk to HTTP, another might have a list of custom tools, another agent might not be using tools, another agent might have 500 tools to use, another might be using MCPs. So a lot of mix and match can happen, making the workflows too complex to deploy easily. Then let's say you have to connect your tools to custom resources like company information, or mainframe systems, or very core microservices and different kind of other resources that you have. And finally, you have to also observe how your agents are behaving. You have to understand each and every log that your agent is generating, each and every interaction that is happening in the production, because you have to monitor all of these things. So that is why getting your agents from your local to the production is hard. However, there are different ways you can do it. One of the ways is Bedrock Agent Core. Now, I'll not go deep into Bedrock Agent Core because it requires significant uh, prerequisites like knowing Python, coding, agents, agent core, the principles of agent core. But let me explain to you simply what agent core basically does. So let's say you have an agent, okay? This agent is going to get flight information, book tickets for you, and also suggest you vacation locations. So what will happen is, to run this agent, you need a runtime. You cannot run it on your local and give it to your customers to use it. You would need, of course, a secure cloud deployment where this agent can run, and it should be available 100% of the time so your customers can use it. So you need this agent core runtime. Agent core runtime to run your agent, which is scalable, secure, and easily maintainable. Once your agent is up and running, then let's say your agent wants to have all the access controls. Like, let's say, a customer would have a different access type A dash, whereas an admin of this agent would have B dash access, whereas let's say CEO of the company has a C dash type of access. So these kind of access that you are maintaining, this is done by agent identity, agent core identity. Yeah, identity manages the different personas who are going to access this agent and who are going to interact with this agent. Now, there could be an agent itself interacting with this, and which has, let's say, D dash type. So again, it falls under agent core identity. Now, once you have this, let's say this agent is starting to interact. Now, I am a user. Let's say this is Ananya. Yeah. Now, Ananya is asking a question to this agent. Book flights from Delhi to Mumbai on 29th of Jan. Yeah. So 29th of Jan, book flights from Delhi to Mumbai. Now, this agent has to break down the steps. For that, it will use tools. And how it can get tools? It can go via agent core gateway. Yeah. Now, I could have custom tools. These are my custom tools. And how I can deploy custom tools? I can deploy them in a Python function, Java, whatever it is. I can deploy them on something called as AWS Lambda, which is another service. Yeah. This is a serverless service for providing deployment for your functions. Yeah. Or I can have something on the web. Yeah. This is a web tool. HTTP, let's say HTTP request. So Agent Core Gateway provides secure connection to these tools for this agent to invoke and use them. After that, once you have gateway, now you will get a lot of conversations. First step, I asked Delhi to Mumbai 29 Jan. Then I said, hey, can you add food also to this? Or what kind of food is available on the flight? Or can you select seat 4D for me? Yeah. So something, multiple turns of conversations I am having. So what these conversations will be, let's say I say conversations. How these conversations are maintained? It is maintained in agent core memory. Remember in strands we talked about sliding window and conversation history, but that was very agent specific. In your production, you have not only one agents and one conversation memory, you have a lot of conversations happening, a lot of memory to be saved. So for that, you use agent core memory. It saves the history, the state, and the session and the metadata of your conversations. After you have done all these, you would want to track what your agents are doing. How many calls to APIs? How many? How many tokens? Yeah. Let's say how many security breaches happened, security traces. So for all these, who accessed? Yeah. Who accessed in last 5 minutes? Last 5 minutes. For all these kind of traceability information, you will use observability. These are again features of agent core which you will use, but ideally these features are responsible for specific tasks. Identity for maintaining access controls, gateway for providing secure access to tools, information, databases which are available either internally or externally, memory for saving your information and conversations, observability for all the traces that are happening or activities that are happening, and runtime for providing you the secure and scalable platform to deploy your agents and share it with customers. Now, this is whole agent core. The same thing, for example, you need runtime to run your agents, strands agents, lang graph, lang chain, whatever. Crew AI, and then finally you go on, you have gateway, which provides access to either browsers, HTTP tools, web tools, Lambda requests, whatever it is. You have identity, maintaining the controls. You have memory, remembering your conversations, and observability, having a log of all the things that are happening and giving you information of all the traces, tokens, access, a number of breaches, security traces, audit trails, everything. Any question still here before I explain with one particular use case how we are doing it?
Ma'am,
Yeah.
I do have a question. Like when we are talking about the agent core gateway, and when we are talking about how the agent is accessing tools, ma'am,
Yes.
is it also getting the same kind of overhead which it would be getting in a normal Strand agent or MCP agent, or is it more like the overhead is more when we are doing that gateway interaction and trying to call the tools?
Okay. So, Agent Core Gateway, think of the same way how when we deploy applications, we have a application gateway that acts as a firewall between you and the application. Same way, Agent Core Gateway also maintains that balance or the firewall between the external things and the agent. By external things, it could be internal databases, internal custom tools, external information. You can have Lambda specifications where you have Python or Java code. You can have OpenAI specifications, and you can have a lot of things. The overhead is definitely manageable in Agent Core compared to the ones you would have in your single agents.
Got it. Okay.
Excuse me. So we'll jump on to the questions and then I'll come back to the customer support agent. One second.
I do have a lot of questions if you are.
Yes, you were saying something. Sorry,
Yes,
I.
ma'am. I have noted down a lot of questions for you. So, ma'am, should I start with them?
No, before I'll just ask some questions and then we can jump on to the participant questions.
All right. Okay.
Yep. Okay, so if someone can tell me what kind of agent core feature you will use for monitoring tokens, will it be observability, identity, runtime, or memory? A. Someone said C. Okay. Okay, so people who said A, you are right. The one person who said C, go back and view the recording again. So, runtime helps you to deploy your agents, observability helps you to trace all the actions happening, all the logs that are happening, starting from monitoring tokens to how many tokens got utilized, how many tokens got generated, all these. Next question. Uh, Agent Core Gateway, can it connect with Lambda functions with Python 3? Yes or no? Okay. Are you sure it can connect with Python 3 or is it Python 2? The answer stopped coming. Okay, so it can connect with any version of Python, irrespective of the Python version. Lambda functions can have Python 3, Python 2, Java, or any other coding specification. An agent core gateway can connect with it. Okay. And finally, which agent collaboration has many to many agents? Like each and every agent talking to each and every agent. Is it hierarchical, graph, or agents as tools? B, graph. Yes. Someone mentioned C. So C is not correct. Agents as tools is again the same name of hierarchical agents, where you have expert agents as tools and there is a supervisor who is interacting with different agents. So the graphs or peer to peer communication is the correct answer. Okay. Okay, so I'm done with the questions. Anyone has any questions? I know one person has already mentioned that they have questions. I'll stop sharing. I see.
May I ask one doubt?
Yes, yes, please, Biplab, go ahead.
So, for like, if we want to work in related field, like wherein we are deploying the AI agents in production, do we need to target any certificate to get opportunity into this area, or is it okay to have the skill and we can apply for job? Like, how is it?
Okay,
If we have to target certificate, what certificate we should target?
sure. So, see, this is a very relatively new concept. Of course, there are a lot of certifications in Gen AI that are already in the market. Agentic AI is a concept which you can build with. However, there are certain learnings you can do, not necessarily certifications. And I would tell you the industry now prefers a lot of hands on as compared to certifications. If you are able to execute it and if you are able to master it, you should be able to get jobs. There are certain YouTube learnings, and I'll share with the organizers and the host the deck, the resources, and also certain YouTube learnings or maybe AWS specific learnings that are already there, which you should be able to go through and build on your skills on this, Biplab.
Okay, thank you.
I'll take questions, two questions, and then if the host can share my LinkedIn and everyone who has questions can drop me a message on LinkedIn, I can definitely get back to you or schedule further one on ones to assist you with the questions. I'll start with the first person whose hand is raised, Shankar.
Yes, ma'am. Ma'am, as I have already said, the like that I have used Cairo, and it's a very good idea actually.
Yeah.
So the way it is building applications is amazing because it is having the specs feature and build feature. So I have used the spec features particularly and the build feature also. So it's creating the requirements, the design.md files and all.
Mhm.
But it can generate the front end very nicely, and any agentic ID is capable of doing it given the requirements properly. So I am giving the requirements as per the project, right? But the problem I'm getting is whenever I'm trying to integrate any kind of database or the backends, it's producing some sort of uh, database errors or the routes errors.
Okay. So,
And this all
what I would suggest is just check if the access keys. So, are you using external databases or again AWS database services?
external database like Superbase and all.
Okay. So for Superbase, I would suggest go through Kiro Powers because it already has an integration with Superbase. So try that out. And if not, check a lot of people who have been participating in AIB, which is AI for Bharat, have the questions like how to integrate with databases. They are also getting certain errors when integrating with external APIs or LLMs. The keys which are API keys which are listed are the private keys which are being shared here. So those could be an issues if the keys are not matching properly. Could be an issue. check the credentials that you are giving the agent, and if the agent has access, read and write access both to the database. So these things you should check once. And for the other errors, generic errors on the backend side, you can chat with Kiro and figure out the errors. Like, it can assist you with the errors if it is very core to your service or the application that you are building.
Ma'am, it is generating the code very nicely. But whenever I'm asking Kiro the question, or any agentic ID, the problem with this agentic ID is, first of all, it's saying that, okay, this might be the cause of the error. Now, when I'm asking it the second time that, hey, you have solved the error, or I have tried to attempt solving the error, the next time it is saying that, okay, this might not be the cause of error, something might be there, other causes might be there. So,
Uh,
and because,
okay. I would have to look at this error. So you can just send the error screenshot and the code which you are trying, not the code exactly, the code snippet where this particular error is coming on my LinkedIn, and I can assist you with that.
okay, this is very project specific. So, that in general, what should we do? Like the way of prompting, that how should we like use the AI
So
tools
best
actually?
practices of prompting are always provide instruction, input, context, and an example, the way you would like it to generate your responses, the way you would like it to use the context. So always give those as the best practices. Again, since it is very project specific, I would have to first look at the problem statement you are trying to solve, and then I would be able to assist you. But nonetheless, just drop me a hi on the chat with your problem and the screenshot. Then I will be able to look and maybe happy to get on a call and solve it for you.
Okay, ma'am. Sure. Thank you, ma'am.
Thank you. The next question from, I see, Prakash.
My question is general, like in AI deployments, how this all memory management is done. I mean, it's a generic question, and just curious to understand, like so much intensive memories are being used.
Yes.
So how all these are being managed?
Yes. So, see, one thing about memory is that you have to always refresh it, otherwise, memory overload will happen. Uh, in general, in production, we have different memory management techniques, starting from managing memory via S3, or managing memory via session managers or file managers. These different kind of session management techniques we use. The best way is always have, whenever, even if you are interacting with Kiro or any other LLMs, make sure that you keep the context different context separate. For example, you can have one chat on your career in one of the context window, and in another you start a conversation about your let's say healthy lifestyle, something like that. So keep the conversation separate is one thing how we do it. Again, in the production we differ the content and the context by intent. So there is something called as intent classification that is done to find out different kind of contexts that are going. One context could be related to scalability, one context could be related to security, another context could be related to something else. Based on the intent, the context is segregated and saved in the database. We generally use S3 session managers for that, which is a built-in session manager for our agents, and that is how we maintain. Every Ideally in production, every 50 to 55 conversations are kept in the latest context, and anything before that is summarized. But that is again very use case specific. Like, if you are defining something for defense, you would like to have a lot of recent context and a lot of context as a summary. However, in the healthcare, you would like to have, let's say, the last five conversations or the last five patient history, and everything else as a summary. So, it depends on use case to use case how you would tailor your conversation memories.
Okay, ma'am. Thank you.
Yep. Uh, any other questions? Just drop me a chat on the LinkedIn. I can take it there. And I would now hand it over to Sujit. Thanks for being such a wonderful audience.
Thank you so much, ma'am, for amazing content and the, what we can say. Sorry, ma'am, I just got disconnected. Yeah, thank you so much for your valuable content, ma'am. Your session was really engaging and what we can say easy to explain. I just want to add one point for the prompt that have people ask. I use one framework for prompting. It's like role, goal, input, element, and output. Role like you want to define the role. Goal is like what you want. Input like you want to use some example. Elements like consider constraint. On output is like what final result you are expecting. So just like five-step formula, all people can remember like role, goal, input, element, output. So that's a five-step formula that I used to be when I'm doing prompting and all. So thanks again, ma'am. Thank you everyone for joining today's session. With this, we are actually concluding our AWS AI series. We got we got quite good engagement from starting. So thank you guys for your continuous support and active participation throughout this series. So if you have any doubts in that all, please ask in the group. We'll take all resources from the host, from the speaker. We'll share to you in the group. So be active on group. Please share your reviews and that all on LinkedIn. And so keep building and keep experimenting, guys. So we'll take more sessions like this. Yeah. So thank you once again. We are concluding this session. Thank you. Bye. Yeah.
Thank you. Bye bye.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.